Alright, hi everybody, welcome. So a while ago, Unsplash released a dataset, so I was wondering what to do with it, and seeing other datasets that are in the web, I thought it would be interesting to just do a Face Dataset with this original dataset. So in this video, we're going to explore a little bit of the dataset, see how to process it, getting the images, process them, creating a new dataset, download the images so we can have the dataset of our own, and yeah, that's it. Let's get started. Alright, so let's start with some titles here. Awesome. Let's copy the imports because they are not that important. And now what we're going to do is download the Unsplash Lite dataset that they provide us easily. So first we're going to say if not os.path exists. This is to check if this the path that we give exists or not, and we're going to download the code here. We're going to use commands here to download the file. The file is going to be here. Copy this in ds. Okay, first we're going to create this folder with make there ds not display, and then going to curl the URL that is going to be this one. Okay, here we're going to use the L option here to follow the redirect. Then we're going to do silent and output. We're going to use this here to make the output. Let's put code here to ensure it works. And lastly, we're going to use star to unzip this file. So we're going to xf and the file direction here. Awesome. And to unzip it in the directory that we want, we need to specify it. All right, that's that. Let's see here if this works. It should. Got something wrong here. Little typo. Let's start with dataset. Let's read this dataset. Okay, with pandas. In a moment, we're going to see the documentation of the Unsplash dataset. For now, let's say that we're going to load the photos CSV. This is a tab separated value, so we're going to use for the separator. We're going to use the tab. Also have 0 because that's in the docs. Let's show the head of this one, so that's that. Let's show this. Awesome. So we got here the photo ID, the photo URL, and the photo image URL. This is the main three that we're going to use, and that's that. We can see here the docs. Let me show you this way. Awesome. So yeah, here are all the fields of the different datasets, and yeah, we're going to primarily use the first ones to make our things. Awesome. Now select these 4 columns, and also we're going to select the AI description column. Okay, so we pass to the main data frame a list of columns to select, and we're going to also print the head of this data frame and see that we have our photo ID, photo URL, and photo image URL, and the AI description. Awesome. Now let's put some markdown here and say face processing function. Okay, awesome. I'm going to copy the imports and we go. Let's show them while we see the code. Now we're going to put this cell that is going to download 2 models. One is the model for finding the box of the face, and the second one is going to be the one that generates landmarks for the face. We're not going to use that much the second one, but for making something else here in this dataset, we're going to show it. So we can go to these URLs and we can see the different models that we have. I'm going to use the frontal face. I think this is one we're going to use, and also we have all of these for the face landmarks, but we're going to use this one right here. Okay, so basically here we define the name of the files, both files. We check if they exist, and if they not exist, we download them. Okay, we set the output to models, and we use $sign here to pass a variable to the command execution here. Okay, all right, awesome. Now let's open an image from a URL using the image library request and bytes.io. So first, let's get the image with the request. Image byte. equal to request.get, and here I'm going to select this one as an example. This is in the dataset, but I had it in my notes. Now what we're going to do is print the status code of this to see if it's correctly getting the data, and we see that we have 200, so we got the request going. Now we're going to reset this variable to the content of this request. This is the binary content of this image that now we can read and convert to a stream with bytes.io. Here from IO we're going to use bytes.io image bytes. Now we can read this stream of bytes with the image library, and we say image open image the open image stream, and we simply create this image in the memory. And in the Jupyter notebook we can just print this image, or I mean leave it out in the last line in the code, and it's going to display it for us. There you go. Awesome. Now with this image, let's create the box, the bounding box, the first model that detects faces. Okay, first let's create a new array from the image. This is going to be a number array. Now let's create with OpenCV. This is going to be the cascade classifier that's going to detect the face. So we got this file here, right here, the name of the file, create the model here. Now let's use the detector, right? We're going to say for this, we need to create a gray image of the source. You need to use CVT color for this. And we just need to, we do CV2, CVT color, and RGB to gray. So here we infer from the model, and this is going to return a list of faces or a list of coordinates that we're going to use to create the box. This is going to be a list of arrays of coordinates that is going to be the X, the Y of the left upper corner of the box, and the height and the width. Okay, so we're going to do that, and we're going to do a for loop of the faces. Grabbing the image draw that we have here, and we're going to create a rectangle with the first coordinate that the X and the second coordinate that is the Y, and then the other points are going to be the X and the Y, and the other corner I think it's the diagonal corner for that one, and yeah, it's going to draw in this image. Okay, lastly, let's show this with Matplot and see what happened. It says that is not defined. Let's see, maybe I didn't run this. That's it. As we can see, we have the box here. Now we're going to do the same, but for the other model. So let's just go over this part of the code, as is very similar to the last one. Here we define the detector, we load the model, and here we, from the gray image and the faces, this is an important thing, that this model needs the box of the faces, the last one, to work. And here this model returns a list of landmarks that we're going to draw a circle on it and put a text to see what the index is. Let's show it right here. Awesome. Now you can do this a little bit bigger, and we can see the index of each point. Awesome. Now what we're going to do is create a function to crop this face, and also add a fill to each side of this box, so we can select how much of the face we want to show. Okay, so we defined crop face. We're going to need the image, the box, and the fill value. That's going to start with 50. We get the X, the Y, the width, and the height from the box. Okay, and now what we're going to do is grab the X value and add a fill. But this fill is, if you see right here, the Y value is this. I don't know if you see the mouse, it's in this direction, right? We need to go up in this direction, so we can potentially go over 0, and it's not going to let us crop. So what we need to do is define Y with fill equal to the max of 0, and Y minus the fill over 2, because we want to have a uniform fill around the face. We do the same with the x coordinate. As it has the same problem, you can go over 0 in the other direction. Awesome. So we do the same for the height and the width, but this time we need to see that this value is not going over the width of the image and the height, the total height and the image. Okay, so first we define that. Let's do height image and width image, and this is going to be taken from image.shape and the first two values. Okay, so I'm going to copy this because it's going to be the same, nearly the same. Okay, so here what we're going to do is change this to H with fill and W with fill, and here we're going to do the max between H image, so the height for the image, and here we're going to change this for Y plus H plus fill over 2. So we are setting this coordinate to be the one of the corner here. Note that when we add to the height, we are moving down in the image, so we are going this direction. Okay, we add fill over 2. Yeah, if this go over the image, it's going to select the whole height and it's not going to fail. What I'm doing this is because in the return function, I'm going to do the width in a moment, but in the returns function, what we're going to do is a slice. So if the slice fail, if the index is not in the height and the width, it's going to fail. And simply in the width with fill, we do width image and we change, let's copy this here and simply change W and H for X and H. Yes. Okay, so here we're going to do a slice between the two coordinates, okay, the height and width. We're going to start the first slice with the Y field to the H field with field. So in a Y, we're cropping from this here to below that. Then we're going to crop from the X field to the H the W field. Okay, great, awesome. Let's run this and now let's test it and see if this works. So image crop is the copy of image open. We're going to show it with matplot. We're going to make the crop of the faces 0 that we defined here, and let's see what is going on. Total fail. Let's see what's happening. Of course, this is supposed to be the mean and not the max. That's why the error here is the mean of this both of these values. Now let's see that we have our crop face. If we want the original one, we say crop field 0, and that is the first box that we have here. Awesome. Okay, now with all of this stuff that we have here, we're going to create a single function that does all of this. Okay, so we're going to go over it. Essentially, it's the same that we have above, but in a single function that we can call in a loop. Okay, so first we ask for the image URL. We ask for both of the models, the frontal face and the face LBF. So here we define the crop faces images, the landmark images. Here in the first one, we're going to save the crop of each face, and the second one, the landmark of each face. Here we create both of models to make the inference later. If the width attribute is set, we add to the URL the width option here. This is an option in the Unsplash API, so we can have it here. I'm going to encapsulate all of this in a try except, so we don't have this function failing and potentially stopping an iteration. And here, as I said, this is exactly what we have above, but in a function. So we get the function here, we open it with bytes.io, we open it, then the stream of bytes with the image library, we convert to gray, and here we detect the faces, and for each face we're going to detect the landmarks that we're going to append to the landmark array. Then for each landmark here, we draw to the image each landmark face. Then we also create the rectangle to the image. Lastly, we append to the crop faces images the crop of the image open given the face box. So this array is going to have all the crops of the face. Okay, Awesome. And that's it. In the end, we return the faces. That's the variable here. Landmarks array, the image draw with all the landmarks and the boxes, and the crop faces images. Okay, now let's test this with the magic command time and see how much it takes for this to run. First, I need to set this cell. Okay, and run this. It's going to take a while. Okay, so first with 1024 is going to be 2.8 seconds, and with 256 is going to be 2.38 seconds. I tested this in an instance, an AWS instance, and it was much quicker. Now let's test the results of the function. Let's do a test run. Let's give it a 1024, the same image that we were using, and we're going to get the image draw result to show all the results of the image. Okay, awesome. As you can see, the landmarks are not set because we have here a flag that is false. If we want the landmarks to be drawn, we need to make this true. All right, there we have our landmarks when we have the landmarks flag to true. Okay, awesome. Okay, let's move to this next part that we're going to do. We're going to process all the images and create a CSV with the faces, with the coordinates of the faces. Okay, this is too big. Okay, awesome. Now let's create an image list. From let's go over here. From this data frame, let's select the URLs of each image. Okay, so let's say, hey, give me the photo, I'm cheating, image URL. So let's select the photo image URL and use the function toList to create a list of this series. Okay, wonderful. Let's now print the first, 3 items to see that indeed we have URLs here. We're going to create a CSV file. So first we're going to create a dictionary to then create the data frame and then save that data frame as CSV. So our result dictionary is going to have the landmarks. It's going to be an array of each corresponding landmark with the original. I didn't want those quotes. Photo image URL. Okay, and it's going to be an array also. You're going to have the side path here that is going to be face box. Okay, great. The image width, to have this running a little bit faster, let's put 256 here. Then let's make sure the path exists. So you're going to use the pathlib library, and to create the path here, we're going to use make directory and exist. Okay, true, and parent true. So we have, if it already exists, it's not going to do anything, and if you want to make, test 2 or test 1, this is going to create the parents necessary. Now let's go over this image list and let's enumerate it. So we have the ith element to save it. Enumerate image list, that. Now we have each URL, and what we're going to do is get the face coordinates using the face processing function. Okay, so we give the URL here, and the width is going to be 256. We can have here the image width variable, so we can have all of our variables in one place. And we can, in a moment, we're going to create all of this a little bit more robust and in a single file script. So we're going to use multi-threading, so this is going faster. All right, but for now, let's illustrate this with a simple for loop so you have an idea of what is going on. Okay, let's copy this. Okay, so now we're going to print and sort of to have an idea what step it is. Let's print the length of the image list and the ith element, the current position in the for. And here in the end we do a return, so we don't print over and over, and we have only a single line. Great. What we need to do now is say if there is a face in the image being processed, we're going to save it in the result dictionary, and let's also save it in the disk to see what photo it is, okay, what image it is. So first let's do CV2, do im write, I did them wrong, im write. Let's do F, and first let's do os.path join to join these two paths, the save path, and let's get from the image list the URL. From the URL, let's get the, as you can see, we have the name of the image here. So we're going to use that to save that the image that we want. So URL split slash with the slashes. I'm going to select the last one. The slash is in the other direction. Awesome. We put here .jpeg, so we have that there, and now we get to give the image that we want to save. So we're going to say get face score. The first result is the landmarks array. I think this is wrong. I want the image draw, so this is going to be the 2, and to have it in the right format, let's flip the RGB, the BGR to the RGB to BGR. So CV2 saves it in the correct format. Oh, one thing that I didn't do is check for the faces. So we're going to check the length of the get faces scored as the first result. The first result is the array of faces, and this we check if this is above 0. Okay, we could do just checking the length of this as if it's 0, it's going to be false, and other values above that is going to be true. But for sake of clarity, let's do 0, above 0. If you want, you can leave this behind. Okay, so if there are faces, we save the image, and also what we do is append to the results dictionary the landmarks and the faces. We're going to copy this because it's important to have it right. So we're going to append to this array the get faces coordinates 0. Then the source image for this one. Let me copy this, and for this one, let's say the URL. Awesome. Lastly, we're going to make the results data frame. I'm going to do pd panda data frame from dictionary. I'm going to give the dictionary that we were saving the results, and then we grab the results data frame and we call the toCSV method with the name Facebook unsplash.csv. We don't need the index, and that's it. Let's also results.head. I'm not going to run this because I want you to watch the next part that is coming right up, but we're going to convert this to a threading implementation, and then we're going to see results. The reason being is that this is too slow doing single core, so I want to show you that it's going to be pretty fast because we already have all of this going on. So yeah, let's see how to implement this with a multi-thread. Also, I'm going to show this in an Amazon instance, so the downloading of this is much faster. Okay, let's do this. We're going to create the file get unsplash faces.py, and first we're going to have our imports. These imports are quite a bit, but we are going to explain it as we go along. So let's start doing that. All right, so we're going to have a function that we created a moment ago, but with a couple of changes. Here we have the same things as before, but this time we're only going to crop the face and not process the landmarks of the face. So here in the last part of the function is the most different. So here, if we detect faces, what we do is create a dictionary with the photo image URL and the face box. We append the image URL, and this image URL is going to have the width that we download the image, so we can have an idea of the original image size. Then we append the faces in this face box, in the face box array, and then we create a data frame with pandas and the dictionary. Then we save that to a file so we can later we're going to merge all of these files into a single one. Why I'm doing this is because we are going to use multi-threading now. We cannot have a single variable to store this data because it's not thread safe to do so. So we're going to save the data to a single CSV file. Then in another step that's going to come in a moment, we're going to merge all of this data into a single one and also do some processing to get the final box of the original image without the resizing. Okay, we have here our function that creates a CSV that has the URL and the all the face boxes that the or cascade classifier generates. Great, now we're going to have a function that is going to be the argument parser. We're going to have only one argument here, and we're going to use the argparse argument parser. We're going to have the W as the worker number that we want. Then we parse these arguments and we return here. Now what we're going to do is use the if name condition here, if name main, to run from the terminal. Okay, first what we do is get the options. Okay, so this part is very similar to the cell that we saw a moment ago. Here we read the CSV, the photos CSV. We select the photo ID, the photo URL, the photo image, and the description. We could do this in a single step, but I don't know, I did it this way because maybe it looks cleaner. We print the first 5 so we can have an idea of what we're going to download. And we're going to have two variables: the save path, that's the path that we're going to save our data, it's going to be Facebox, and then the image width that we want. We could do these variables in the options here. I might leave this to you if you want. So yeah, then we ensure that the path exists with the path library. So we give it to the constructor here the save path, and we execute the make direction method with exists true. Great, now we're going to create a function to give to all of the threads that we create. Okay, we're going to call this function get faces th, and we're going to give the URL to this function. This function is going to have get faces chords equal to the function that we have here. Here we pass the URL and the width that we want as image width. Okay, this way we have we need a single argument function to give to the threads. I think that's the better way to do this. Then we return here the status of the request and see, I don't know if there's an error or anything. Also, now let's create with the thread pool of threads to execute each function. Great, so we're going to do with thread pool executor as executor. I need to create the instance here, and here we're going to pass the max workers as option W. So the options here is the argument that we pass to the script, and here we have the options W. Now here we're going to create futures that are going to execute the images that we want with the get faces th function. Okay, we're going to create an array of futures with executor submit, and here we're going to pass the function and the image URL for, I think is image list, for image URL and image list. So why are we creating a list of futures? We're creating a list of futures because we're going to add to each of them a callback to see the progress of the whole execution. If we don't do this, this should work as now, but we're not going to have any indication on how the process is doing. Okay, so first of all, we're going to create a log. This log is going to enable us to have a thread safety. Each thread that wants to access these variables inside the log needs to, it kind of blocks the variables to be in access to other threads, so they don't like try to write the variable at the same times or something like that. Okay, we're going to create task totals here as the length of image list and the task completed. We're going to create it to 0. Great. Now to each future, we're going to loop over them. So for future in futures, you're going to add to each future, add on callback, and a function that's going to be executed when the future is done. They're going to call save and print. Okay, I don't know why I choose that name, but that's that. Okay, awesome. So let's create this function here, def save and print. It's going to have only one attribute, that's going to be the future. So here what we're going to do is access the global variables of log, task total, and task completed. So we define in the scope of the function global log, task total, and task completed. This is to be able to access those variables and have the same value. So here using with the log, so we log all of these variables to being used for other threads. So only a single thread can access these variables using the log. We do task completed and with some one. Awesome, that's that. Also, we're going to make a print here. So task completed, I have a typo. So let's change that. Task total, I also have a little bit of typo. Okay, yeah, and this is just a print with the result of the future, the task completed over the total tasks, and the remaining task, that is the total minus the completed. All right, and with that, we should have our script done. Let's see this execution in Amazon instance so we can see the speed of this script. Okay, so here we have our terminal in our Amazon instance. I'm going to do Python get splash faces.py. I'm going to say 8 workers and hit, and as we can see, we have our process. If you can see, this is way faster than doing each one, so this is an awesome improvement. And if we do an ls in the Facebook's folder, we can see that we have anything because we didn't find a face yet. Let's leave this working for a little bit and see if we have some results in our folder. Okay, so this is done, and let's see now with all the 25,000 process if we have some here, and we do. So here let's select random one and do cat face box and the sample, and we can see that we have here our list. Here's a bug that I didn't anticipate, that we have this format and we cannot evaluate this format. So in the next part and the final part of this video, we're going to see how to process that format and convert it to the full Facebooks of the original, as this one is for the 512 size image. Let's see if this actually has a face, and it does, and it's the one that we were using before. So let's try another one. Okay, so let's try this one, and also we can see that there's a face. Let's now convert this format to more easy format to evaluate, and then resize the box to the full image. Alright, so in this part, we're going to resize the bounding box that we generate to the full image, and then we're going to merge all that data into a single CSV file to then, in the last part, download the images with a script. Okay, so we have now a folder with all of these CSV files. So we have our imports here. First, we're going using the globe method in the globe library, going to list all the files that have the CSV extension in it and having the CSV variable. Then let's read the first, the number 6 in the list to be an example. As we can see, we have the Facebooks here, but it's in a weird format because there's no commas between the numbers. So we need to evaluate somehow this. Okay, here we print this. So first, what we're going to do is replace all of the brackets with nothing and split the string with the spaces. As you can see, we got some white nothing in this new array, new list. I still call it array list because I'm using NumPy. Then what we're going to do is grab the thing that we have here and use comprehension to basically say if I is not null or empty, let's grab it and use it as an int. Okay, so we run this, let's print it out, and we have our list here. think that's about right. Now let's see how to change the ratio of the bounding box. This is pretty easy. What we need is a ratio between the original computed size and the target size. We know that the original size has width 512, but we need the height. That's why we need to retrieve the image again and compute that, or ask for that, the shape of the original one. So what we do is here the crop face, the function that we saw a couple of times now. What we do is compute a ratio that we give to the function, and that we multiply the x and the y coordinate with the ry and the rx, that the ratio of the y direction and the ratio of the x direction, and we do the same with the point of the other corner, and that's about it. In this function there is a little bit of a change because now we add the field based on the height and the width of the box and not a pixel one. Okay, awesome. Now let's do an example here. Let's retrieve a function. We grab the shape on this variable, and as you can see the face here. Now we grab the original image, we split the question sign, and we select without the option, the width option, and we get the original size and the new size. As you can see, the height and the width, I think it is. And now we compute the ratio. So new shape divided by the original shape in the x-axis and then in the y-axis, and we have here the ratio 7.5 between the computing and the original. And what we do is simply call the crop face with the ratio that we need, and we get the result. Awesome. Now we can add a field based on a percentage of the height and width of the box. I think that's a better way of computing, enlarging the box. Now let's do how to merge all of this data and recalculate each square into a single CSV file. This is pretty simple. First, as a new function, we have parse chords that is the same that is doing before, but in this time we are reshaping it. So we have, if there's more than one face, we reshape it with the NumPy reshape to have as many 4 sizes array as this function calculates, and then we simply return coordinates. I have an example in a second. We have the recalculate box. This is pretty similar to what we do in the crop face function, but here we simply recalculate the box and we don't do any crop. Okay, so we have a new y, a new x, and a new h, a new w, and we simply multiply by the ratios and we call int, so we have an integer. That's pretty much it. This is going to return a list of lists. Then we have the crop face function that is equal to the last one. Let's assign this variable again. This is like a recap of what we did before. Here's like a single run to calculate one image. First we retrieve the original size, then the new size. We calculate the shapes. We call the recall box, and we have here the original size. I think there is, yeah, and the new box. So we run this, it's running, and then we can plot with the new box. Awesome. Finally, we can do this into a for loop. So we enumerate the CSV files, we're going to create our result dictionary. So then with that, we create a new data frame. Okay, so again, we recalculate this variable, we create a dictionary for our data frame, we enumerate the CSV files, then we load the current file, we encapsulate this in a try except, so the for loop doesn't end for a single error here, and that's pretty much it. Here we calculate what we did before, and we append the recalculated box into the face box chord and the current image without the width into the photo image URL. Yeah, and finally in the end we save that result into a CSV, the merge face chord. Then we're going to using this file, we're going to download the final faces box. Faces box? I don't know. Alright, the final sprint. We have here the script that is going to download each face box. Okay, so we have our crop face, pretty cool to what we saw a bunch of time now. The get options that get the option for this script. Here we're going to need a source, CSV file, and the output function. Okay, as we get the output function as a default to Unsplash faces, and we require the source face, the source CSV file. Okay, so we get here the options, and we're going to ensure that we have the output folder made. We call the make directory of the path live with execute and parents true. So we create the parents and we don't have an error when the folder exists. We load the CS file with source with this separator as we say right here, and then here we simply iterate the rows. This is a pretty simple script. We're going to evaluate the faces box. In this time we can evaluate because in this step we save it as the correct format with a comma, and we save in the CSV file with this separator, so the CSV files know what the column correct is. Then we get the current image, we request the image, we load this image with binds.io, we convert it to an number array, then we get the name of the image, doing a split and selecting the last sort of string in this array. This is to have a name to download it. Then we do another for loop to the to the face coordinates, because there can be multiple of them. Then here we simply crop the face with the crop face function, and we try to save this. We do this because sometimes if the crop is null, CV2 is going to throw an error, and maybe that breaks the for loop. We say, hey, we have an error with this image. For printing, we print the current iteration and the length of the source CSV, and that's pretty much it. Let's see around on this somewhat short and see some results. All right, so after executing this and saving to the merge face court, we have our final CSV file. So we have here the original image and then the face box coordinates. Let's now run the download script. So we now execute this command. So Python download Unsplash faces, and we specify the source CSV file, and we hit enter. Let's see. The Unsplash face is going to be the folder is going to be created, and let's see the faces. Great. Now I don't know, let's see a couple of them to see that the faces are downloaded correctly, and I think this is a success. Awesome. Okay, see another one. Great. Now let's cut this out and clear the terminal, and that's about it in the project. Hope you liked it. If you do, give it a like and subscribe, and yeah, follow me on Twitter if you want to reach out and talk to me, and I'll see you in the next one. Goodbye.